Good afternoon, everyone. I think we'll just give for some time for people to join. Even I see almost everyone here. Kennedy,
Yes, sir. Good afternoon,
yeah, how
sir.
you doing? Good,
I'm good, sir.
good. Okay, we'll just give for some time, give like 5 minutes, and we'll kickstart.
Okay, sir.
Our facilitator is already online, so Kennedy, you want to say hi? Or you want to?
Of course. Yeah. Good
Yeah,
afternoon, everyone. It's morning here. Uh,
yeah, that's true.
I'm really excited to see, you know, people turn out, for the launch session to, hear about continuous improvement, Six Sigma, and the likes. Um, let's see. Let's give some people a little more time. Dominic mentioned that we usually have like 20 to 30 participants. So, and sometimes we try to understand African time. So we'll just give about 5 more minutes, then we'll kick off.
Yeah,
Is that fine, Dominic?
yeah, that's fine. That's fine.
All right, great. Thank you, everyone.
So once it's 2:05, we'll start. And so we always have this challenge of going off when it's, let's say, approximately 40 minutes. So we just rejoin for the next, I call it the part two.
Okay,
Yeah, so
great.
some house rules or housekeeping. I think everybody should be on mute when the facilitator is speaking, so we don't have unnecessary interferences. Yeah. So we could ask questions through the chat option. I would collate and keep for maybe after the first section or at the end of the entire section.
Yeah, sounds good.
Okay, great. I see we are 11 now. Okay, so I think would Chilling, I'll make you host now, right? So you can start
All right,
just
that works.
to, yeah. Thank you once again for taking out time for this. I know it's early there, right? This should be like eight
Yeah, it's
o'clock or
9:05 now.
9. Oh, okay, better
Yeah, so we
than the
gained one
last one.
hour. So yeah, unlike so sometimes the time zone changes from 6 hours behind to 5 hours behind. So
Ah,
in
okay.
summertime we're 5 hours behind.
Wow. Okay, great. Okay, so you're good to go. I think
All right,
yeah.
great. So thank you everyone for turning up for the session. When Dominic asked me if I could help co-facilitate this session, I took it by the horn. I was like, yeah, sure, I'm always willing and available to help share my knowledge, and share my experience, and also by co-learning, I also learn and try to get better at what I do. Please pardon the occasional accent, sort of, even though I've not been here for long, but I still know the effect being around in another climb can have on the way one speak. So I'll try to be slow and just to be very effective. But I know they try funny. I'm a Niger boy, you understand. So just a little bit about my background, right? So I've let me share my slide. Share my screen. Okay. So I need to. So let me share. Swap the views. Okay. Yeah. So everyone should be able to see my screen now. Um, I'm Chinedu. Okay. I've had around 10 years experience in manufacturing, cutting across IT, my earlier stint, to manufacturing excellence, which is continuous improvement, and business process improvement in companies like Cadbury, Unilever, BAT, then in Canada here, Molson Coors, then Treehouse Foods. So earlier in my career, I started as a management trainee at Cadbury, before moving to Unilever as a shift manager. I moved into continuous improvement when we launched a new program called manufacturing excellence. I was part of the pioneer team who helped put in the current Unilever production system in place. I did that for some while before moving to British American Tobacco. We were launching a continuous improvement program called Integrated Work Systems, IWS. It's called after the P&G methodology. We're trained by Ernst and Young, the consultants and all. Did that for some while until 2018 when I moved to Canada. So joined almost immediately to Molson Coors, a company that makes one of the biggest brewery in Canada here. Then I moved to as a continuous improvement manager to Treehouse Foods, which is where I currently work. I'm happily married with 3 children. We had a little baby 2 months ago, 3 months ago now. So which makes our kids three. The initial ones were a pair of twins, and I'm really proud of them. I tell them that they're the reason why I go to work every day. So in my spare time, I love playing tennis. I'm a project management professional, a Six Sigma black belt. I've got expertise in lean manufacturing and project management. So that's just a bit about me. I know in due course I'll get to know the team and all, but yeah, I just want to thank everyone for joining, and I hope that we learn. I'll try to make this session as interactive, so we could use the Zoom chat box, to ask our questions. Then when I call for when I call for information, for instance, I could ask what are the takeaways we want to have, something like that. Then we should just use the chat session to be interactive. So the objective of today is to provide an overview um, of Six Sigma, understand the roles and responsibilities in a Six Sigma environment, and also to introduce the defined phase of Six Sigma, right? So I would like at this moment for us to, comment in the chat box session. What are some of the key takeaways we want from this session? So please type in the chat box. What are the things that we wanna see? What are the things that would like to, just some key takeaways. Okay. So I see in the chat. I see. Yeah. What are your expectations from this session? What would you like to get, everyone, from the session? Maybe it could be things you want to learn, things you want to know. What do you think? What do you think? Six Sigma. You've heard about it. What are your expectations? What do you want to know? What would you like to learn? This will help me channel the conversation towards those areas that would like to learn. So if you look at the the menu, you're going to see more, and you can, put participants, you're going to see chat. So at the chat box, put in what you want to say. Okay, thank you, Martins. Martins Okon is saying, I'd like to know how to effectively implement the methodology, and get actual results in the bottom line improvements. That's great. Thank you. We're going to, try to cover that. Actual improvement in bottom line. Who else? Any other expectation? Okay, so Ongo Africa is saying how Six Sigma can be used to reduce waste and improve production output. Yeah, very important, because waste is one of the, we call it muda, right? In the Japanese term. So it's one of the, for wastes. We've got, 8 types of waste. Some say 9, but I would say 8 type of waste. And it's really critical as in manufacturing to reduce waste, because that's the best way we can add value. Okay, waste is muda Japanese, yeah. Any other takeaway before we commence? Okay. Okay, Adaku Odidika is saying, I would like to understand the critical success factors for Six Sigma implementation. Okay. Yeah. So I would make sure we cover that. Okay, as we we get our thoughts together, we can put them there. But yeah, thanks Martins, thanks Ongu, and thanks Adaku for your input. All right, let's go on. So so we're gonna as well at the end introduce the defined phase of Six Sigma. Now we could say, why Six Sigma, right? What is Six Sigma? So I just put a small, something here to say what is Six Sigma and what is not, right? So some people, think Six Sigma is, it's all about statistics. It's this crazy tool where people perform magic in. No, it's just a target. It's a performance target, right? So in Six Sigma, I want to get to what we call the perfect spot, which is having in 1 million defects, you just have only 3, right? So we just want to be at that point where we can in 1 million production just 3 defects. So Six Sigma, perfect, right? It's a performance target. That is where we want to get to. That is where companies want to get to, so that there would be less mistakes. We can improve customer service and satisfaction. It's not a statistics program. It's not something we can call a quality program, although it has quality bits for it, but it's more about a process. It's not owned by one department. It's not CI. It's not owned by CI. It's not owned by quality, right? It's a business process. It involves the whole organization. And that's why Six Sigma can be channeled in different work streams. It could be in IT, it could be in, inventory management, it could be in manufacturing, it could be in auditing, whatever the process, right? Six Sigma can be applied there. It also comprises targeting and variation, because variation is the enemy to success, right? Is the enemy to manufacturing, because for instance, you want to buy a chocolate bar or you want to eat maybe a biscuit, right? You would like your biscuit to taste the same every time. You would like your biscuit to have the same round shape every time. You would like your biscuit to be properly sealed and all, right? So it targets and it tries to eliminate variation, right? Let's make the product right the first time, every time. It's not a training program. Yes, you can be trained on Six Sigma, but it's not for training. It's for getting results, performance targets. It's for improving the business process, and it targets variation. So some history, right? It began in early 1980s at Motorola, widely adopted, and Six Sigma was very crucial to General Electric success in the 1990s. Then we had a man called Jack Welch. He's a man I admire so much. So Jack Welch, kind of launched Six Sigma in the company when he was CEO and all. as part of their executive ambition and their vision, right? So Six Sigma really permeated the organization such that, they overtook the number one company back then, and, they became number one in all their categories, right? And, they built on that success over the years. So it's a program about solving problems, making decisions with data. So it's very much data centric. It's a program about accountability. It's very rigorous, right? And it's actually a big commitment. So what's the journey like, right? So if you look at these charts, right, we've got operating at 2.5 to 3 sigma or 1 sigma around the left. So what people do then, we do quality management, we try to problem solve. We want the quality to be perfect at the customer. So if there's an issue, right, we can actually, oh yeah, we have an issue in production, so we can take it off from the warehouse, right? So we have quality hold. Oh, it escaped our quality gates, and the product got to almost at the market, or it's at the key distributor, right? But we can actually call it back. So that's where we see some of these then. So we try to control the process output. Well, that could help in a way, but it's not where we want to be, right? Then we move to the middle section, where you have process improvement management, perfect quality at the next operation and at the customer, right? So we start moving back to say, oh, as opposed to getting it from the customer, right? How do we get that perfect quality maybe when it's at the end of line? Or how do we get that perfect quality in the warehouse, right? So we control the inputs to predict process outputs. Someone is raising the hand. QC lab. Okay, so you cannot hear, please. Can everyone hear me?
Yes,
Hello.
I can
You can.
actually.
QC lab
Yeah.
cannot hear.
So I've just put in the chat box that you should try rejoining.
Okay,
Yeah,
okay.
I would just don't worry. I would communicate. I will work with the chat. So
With the chat. Okay, so I
yeah.
don't get.
So
Okay,
yeah.
that's fine. Thank you.
Okay.
Yeah. So we have the third phase, which is designed for Six Sigma, right? That's the perfect spot. That's where we want to be. The previous spot operated between 2.5 to 3 sigma, 4.5 to 5 sigma, right? So again, at the point the process is capable, process is stable and predictable. There could be some few issues, then it can be fixed. But we design for Six Sigma. It aims at perfect quality before production, before the next operation, and also at the customer. So it's end to end, right? We want to ingrain quality into everything we do, such that our product is right the first time. We don't have to worry about recalls. We don't have to worry about doing multiple quality checks and all. The quality folks will kind of focus on improvement, right? Improvement to the current process, right? And not just putting hold tags or maybe preventing recalls. So it's more like a proactive method to manage quality and customer expectation. So I'll use this example to slide, right? So in Three Sigma, you have, like, in a page of books, right? You could have over, let's say, 1,000 words and all in a page of book, and you're looking at 1.5 misspelled word per page, right? That's operating at Three Sigma. Or you could say in time, 3.5 months per century, right? A Four Sigma could be like you misspelled one word in a 30-page book, right? So you see that you're getting better, right? As opposed to misspelling 1.5 words in a page, it's gone to one misspelled word in a page that has, like, a book that has 30 pages, or maybe 2.5 days in a century, so 100 years, right? You move to Five Sigma. Five Sigma would be 5 sigma would be one misspelled word in a set of encyclopedia. So let's say dictionary, several dictionaries, just one misspelled word. You're getting better. Or 30 minutes in one century. That's the mistake, right? That's the defect. So yeah, it's improving, but that's not where we want to be. With Six Sigma, it's like one misspelled word in all the books in a library. Just imagine that. That's near perfect. It's like only 6 seconds, mistake in a whole 100 years. That's almost infinitesimal, right? Or unnoticed. So we'll call it 0.003% mistakes, or maybe 3 mistakes in a million, right? So that's our Six Sigma. That's where we want to be, and that's where every performance should everybody here as a participant should be aiming to go, because that's utopia for us. That's the perfect spot. Yeah. So it's a way to fix problem and make our decisions with data. Six Sigma aims at data. It's a data-driven approach, right? We want to understand a process better, but we have to use data. We want to improve process capability. We want to reduce variation, right? Variation is the enemy of perfection. So we want to reduce it by all means. I want to improve output, right? Want to improve output. Want to reduce waste. Like how Uncle said, because if you don't improve your output, right, you have more waste. But if you reduce your output, if you improve your output, you have less waste, because you don't have to worry about getting imperfect products and all. So it's a data-driven approach. It's very much structured, and it's a team approach, right? So use this to clarify the decisions in Six Sigma are based on facts, not opinion. It's not what someone thinks. It's not what we think. We have to use data. We have to remove guesswork. Guesswork is waste, right? If we guess, oh, let's try this method. That method doesn't seem to work, right? Can we try another method? It's waste, right? It's using data and facts, leading to focusing on the problem. It's not politics. It's not personal opinion. It's not what my boss wants. It's what the data says. You know, Data have no department or division borders. It's black and white. As far as your data is accurate and correct, that's what speaks the story. Where it helps us, it's structured. So if there are complicated problems, there are losses that are chronic, there are losses that are systemic, losses that have always been there right from time. It's designing a process. That loss is there. Six Sigma helps us handle those problems. It also enables us to use the same problem solving, in all departments across all divisions. So many of us work in companies that have probably several divisions or several other branches, right? So if Six Sigma is the way to go, right, it's going to be the same whether you're doing it in Asia or Africa or North America. It's the same way. So it transcends every division and every climb. It helps. It also has to do with team, right? Again, an African adage says, if you want to go far, go fast, go alone, right? But if you want to go far, go with people. So it's teamwork. Teams can solve harder problems. It's been demonstrated. Teams have more knowledge and experience than individuals. No man is an island of information, as we know. So we need to leverage each other of our strengths, right? I remember projects that I've worked with and all. The best solutions actually come from the operator, because these are the guys that see these issues every day. They are the ones we can just see it a couple of times. We can be on a high horse or on a helicopter, having a helicopter view, but the guy with the boots on the ground, the frontline soldier, those are the people that actually see the problem well and can actually give that solution to them. One of the reasons Jack Welch, one of the people I admire in General Electric, invested in Six Sigma, he mentioned that someday during a long service award, he was giving an award to an operator. Right, operator has worked 30 years. You're giving him 30 years award, and he was shaking his hand. You know what the operator tell him? That don't shake my hand, because for many years, right, you have used my hand, whereas you could have used both my hands and my head. You know what that means? The operator is saying that I don't want to just be punching, buttons and making this machine run. I want to be able to use my brain and solve problems. And that was a turning point in Jack Welch's life, such that he invested in Six Sigma and transformed General Electric to the big company that a lot of us had come to admire. Teams generate more ideas, team accomplishes more. But again, what is it? It's a culture change. We want to fix problems and make decisions with data in order to do all this, right? So it requires a culture change. So our managers could say today, why do you want to do this? So you bring something up, you say, oh, I find a way to improve the process, I want to do this. So and a manager will say, what do you want to do this? But the company, which is a Six Sigma company, which is the Six Sigma culture, would say, show me your data. I want to see your data. It's not saying you're wrong or what. It's just validating those assumptions. Because until whatever improvement we have, we say, oh, it's going to improve the process. But until you can quantify that in data, in actual black and white, in naira and kobo, in dollars, right? That's when you can truly, add value. So people could say, we always do it like that, right? We see it a lot. This is how we've been doing it for 30 years. We've always done it like this, but a Six Sigma company will say the current method is 5% faster than other options investigated. So it shows that you've used detail, rigor and detail, right? To look at the other options, look at it, then come up with a clear problem statement. Some organization would say, oh, it takes engineering forever to process an engineering chain. It takes them forever to fabricate a simple part. But again, forever is relative, right? It's ambiguous. So a good statement would be engineering change averages 3 weeks with a spread of 1 week to 2 years. So you've talked about the average, you've talked about the spread. So then you can now say, how do we narrow the spread? How do we reduce the average? How do we make that um how do we make it, like Six Sigma capable? Someone could say suppliers are sending us substandard parts. Or it could be the reject rate of the current supply is 4.5% since December. So it requires a cultural change, the cultural change of using data. Now, what's the cost of not doing it right the first time, right? Which is cost of poor quality. Yeah, I saw this in the last session. I think Dominic hosted. He talked about cost of poor quality, right? So usually it's like an iceberg. Remember what crashed the Titanic, right? So the Titanic, they saw, the tip of the iceberg and was like, oh yeah, we can go around this, right? It's just a small iceberg, but that's just only 10 to 20% of what you see, right? There are a lot of things, like 80% of that, it's underlining. So what this is saying is, like in traditional quality, right? We see our quality cost. So we see our scrap, we see things like inspection, warranty, right? Reject. But again, there are a lot of underlying stuff. It's not just those rejects, it's not just that scrap, it's not the things we dispose, it's not the concessions. Those are just tangible things. That's what you can see and feel and touch. There are intangibles, like, again, cost of poor quality, more setups, because we're not accurate. We don't really know where to put it in and dial it in. We have to, because we can't meet up with the demand or the timeline, we have to freight, we have to expedite cost. We then lose sales because we are not agile. We have late delivery of things to our customers. Again, it results into lost customer loyalty. People are no more brand friendly, and also if they can't see your product in the market, they move to the next thing. If they can't get value that they desire, right, they move to the next thing. Cycle times are longer, engineering changes, orders, so again, statistics have shown that this lost opportunity are, can, which is called cost of poor quality, cost approximately 15% of sales. It's also called the hidden factory, according to Six Sigma definition. So we move to the next one. How does this process work, right? It's 5 stages. We've heard about this DMAIC. You define, the problem, you measure the problem, analyze these problems using tools, which we'll talk about in, couple of weeks and months when we go through the different phases. But for the benefits of this, we're going to talk about the define phase in this scenario. um but I'll walk through us the Six Sigma process first, right? For us to understand the process, then at the second part of the conversation would be where we'll deep dive into the define phase. So it's DMAIC, define, measure, analyze, improve, and control. And there's a basic formula for it. We don't need to memorize it, but it's just what we call Y equal to FX. It just means your Y, which is your output, is a function of your input, right? Whatever you see, whatever you see in a product, it's a function of everything that has gone into it. So if you want to improve the product, right, do you focus on the output? I don't think so. You need to go to the input and ensure that all the inputs are correct. Your process is correct so that you can get the best output. So in other words, if we look at the inputs and make them better, so we want to make things faster, want to make things cheaper, want to have less waste, we want to have less defect, right? Then our output will improve, which will give us lower cost, higher quality, faster delivery, etc. So Six Sigma process step by step. It defines the problem in terms of output, which is your why. It determines the inputs that affects the output, right? So you gotta know what are every input, what is every single thing that ensures that my output is consistent every time. It now does what we call a ranking, which is how significant are each of the inputs. Okay, you could use different things to do a ranking. It could be a Pareto, where it talks about the 80-20 rule, and everything, right? Then it now says how significant are each of these inputs, which one has the greatest effect on my output. That's what we'll start with. The low hanging fruits, the big rocks, we fix those ones first before we go into the little things. We fix the X that was proven to be significant. A lot of times in troubleshooting and all, we see a lot of things and we could wonder, oh, is it this, is it that? But if you can fix that one that you've actually tested, you know, in my while working at Unilever back then and all, doing continuous improvement, someone mentioned that I fixed this problem. And I was like, how are you sure that you have fixed it? It was like, it's never going to happen again. I asked how. I asked the operator how. He said, because he can turn the problem on and off. I was like, really? So until you get to that point where you can turn the problem on again and turn the problem off again, that's when you've understood that this is the problem. This is what's significance. So you check to see if the fix did not negatively impact something else. Right? Again, you could fix something, but it can result into a consequential effect. So we have to check that it doesn't impact something else. It doesn't impact the life of an operator. It doesn't impact the life of the process. It doesn't impact the scheduling time or the time where our orders get delivered, right? Because again, we can be too fixed on the problem and solutions that we fail to consider the big picture. So it's really good to check that number 6. Has Y been optimized? Are we seeing the output that we want? Can we turn on the problem on and off? If not, we fix the next significant input, X. We repeat it again from step 4. We continue and continue until the problem, Y, is optimized. We use this analogy, getting to work on time, right? Oh, this is one of my favorite because, again, someone arrives to work late and all. Again, the manager, oh, you came late again, right? And you're late. Even for the person who came late and all, the person needs to look at some other things. So the output is what the manager sees. Oh, you arrived work 8:30 a.m. as opposed to 8 o'clock, right? What are the inputs? The time one wakes up. So you could wake up at 5, you can wake up at 6 or 7, or maybe you even woke up 8 o'clock and then you got 8:30, right? The time you take to get ready, that needs to be factored in. So you wake up, you need to take your bath, have your clothes. Traffic, that's one common problem we have in Nigeria. Oh, Third Mainland Bridge is going to be closed for some while. It's going to affect a lot of things, right? So those are the X's, and the weather, right? Each of these X's can affect the time it takes for one to get to work. But how, as Six Sigma people, are we going to say, let's see what is in the data, right? Why am I getting to work late, or why is my colleague, my reportee, getting to work late? So remember, Y is a function of X. Outputs are based on input. If we improve the input, which is time we wake up, time to get ready, traffic, weather, then we can improve the time to arrive at work. How does Six Sigma process do it, right? So it looks at all those things that we talked about: time to wake up, time to get ready, traffic, weather. Of course, if you wake up 8 o'clock and the time to arrive to work and do all those things, it takes like 45 minutes. That's no way you can get, right? If you wake up 7 o'clock, you can't even get there at 8. So you need to look at the time to wake up. It plots the percentage on a Pareto chart to say the biggest impact is time to wake up. So if you want to improve this, wake up on time. For instance, you wake up normally 7 o'clock. Can I do it 6 o'clock? Can I do it 5 o'clock, right? Can I even, in some cases, some even preempt to say, what are those other things that makes me, even after waking up, then I can't get to work on time. That's the next thing. Get ready. What time does it take to get ready, right? Does it take 10 minutes to have a bath, 15 minutes to have a bath, or even are there some scenarios where there's no electricity and I can't iron my clothes, that kind of thing, right? Is it the traffic? Is it the weather? So it plots everything, a chart, and it now goes to the next level to drill down. If you look at the arrow, it now checks root causes on waking up, right? Again, why don't you wake up on time? Is it snooze? Is it the time you went to bed, you know, chatting on the phone or doing something else or doing something value adding even, right? Um, Previous nights and even other. Root cause for getting ready, it could be, the kids, hygiene, it could be, anything, right? Weather as well. Snow, rain, ice, weather, bad weather, everything. Could it be there was an accident that caused traffic, routes, coordination? So it looks at it. So if you want to go for, to solve this problem, the first thing is to fix the time to wake up. Then you check again, right? Now, time to get ready, then so just that way, it just shows that Six Sigma, uses data. I remember in the last session where Dominic talked about Pareto and all, remember, I said that, you're going to use it, it's going to be from, left to right, from the bigger to the smallest. And if there are other things that are called order, right, it should be at the far right. So this actually depicts and reiterates that. Um, the next thing, we look at the problem and say, um, what is let's go to time to arrive, for to work. It now says, what's the problem? Step one, what's the scope? Time to arrive at work. You drill down to the root cause, which is the top bar. Wake up, right? In order of severity, use the Six Sigma tools to solve each root cause until the wake up element is solved. You repeat step 2 and 3 for the next bar, which is get ready. You continue that process until that is solved. Step by step, it's DMAIC. It summarizes this to say you define the problem in terms of an output, time to arrive at work in this case. You determine the inputs, that affect the output. You determine how each of these inputs are, significant. You fix the significant input, which is the cause that has the greatest effect. You ensure that this is sustained. For instance, if the guy is waking up, at a particular time, what can he do, right? You could have an alarm clock to say, I want to wake up, I want to change the time I wake up. Let me set my alarm 1 hour behind so that I can, wake up early. If maybe he sets his alarm and then he doesn't hear his alarm ring, right? Then he could now say, okay, I want to make sure that my alarm is always on ring. Or even if then I can go to a traditional alarm that, or maybe his battery, he doesn't hear his alarm ring, for instance, because the battery died, right? Then he could say, oh, I want to eliminate this. I want to use, as opposed to using my phone because there couldn't be light and all, let me buy a traditional bell, 2 bell and a ringer, right? This kind of old alarm clock that would wake you up even when you're about to die. So that kind of thing and all. So you can't even snooze it, right? So those kind of options will help to ensure that the person wakes up well. So it's about looking at the root cause and addressing the problem. But again, let's expect many causes. There's no silver bullet, right? A problem is solved by drilling down to the problem statement. Look at this tree. You have to go to the rig. You have to go down, right? And the last 2 slides will talk about the roles in the Six Sigma initiative. We have less than 1 minute, then we'll log in. But